Okay, let's look at a cosecant functions graph. How to draw this graph. And I made a few mistakes while I was doing this task, but I'm going to explain it. First, we need to calculate the period, as we did for the cotangent function graph and the tangent function graph. Then we'll look at the A and also amplitude, which is the 2. So we're going to swing 2 up and 2 down in terms of y values. Maximum value. I stopped here, I didn't write it down because we want to do the shift first. So once you know the shift, then you swing up and down 2 units in terms of y, and you get the maximum value to be 4 and the minimum value to be 0. So go ahead, write down 4. And minimum value equal to 0. So up and down. And then step 4, what I wanted to find the first period of the sine function. Sine and cosine functions are to the multiplication result is 1. So okay, let's get the sine functions first period first. So our goal is to draw the sine functions graph, and then we draw the cosecant function. So now we know the starting point, which is 3 pi over 2, and ending point 15 pi over 2 of the sine function. And once we get the sine drawn, we can draw its cosecant function. So took my time to put all the coordinates on the graph. Originally, the sine function's starting point is supposed to be at 0, 0. Now, because of the way we did this phase shift and also period change, now the starting point is going to be the first phase period, going to be 3 pi over 2. And remember, we shifted it up by 2 units, so the y not equal to 0 anymore, equal to 2. So for the end point and the starting point, both. So I'm trying to show you the end point moving the paper. The end point on the right, starting point on the left. The solid dots on the graph system. And we want to know the midpoint between this starting point and end point, so that we know the midpoint is still on this y equal to 2. That's the property of a sine function. So it's going to be on the y equal to 2 too. And now, I wrote it 0. I later on changed to 2, so it's a mistake to have a 0. If there's no vertical shift, it's going to be 0. But there's a vertical shift. See the step 3? So this one has like 4 steps or 5 steps. The last step is like getting all the midpoints and also the maximum value and the minimum values all maximum and minimum for our sine function graph. Then we can graph the cosine function. So I'm trying to find that in activity 2, 9 pi over 2. And when I was looking for the midpoint between the negative 9 pi over 2 and the 3 pi over 2, I made a mistake. I found a 2.5 pi. Negative 2.5 pi is the midpoint, but it's not. It's negative 1.5 pi. So later on, I changed that. So if you see a mistake, just overlook it. Later on, it was corrected. So you see here, I'm trying to midpoint between the period, the period before the period the left period, I'll call it, and that is 3 pi over 2 negative. And yeah, I corrected that. See, the y equal to 2, and this y equal to 2 too. And when I'm looking for 3 pi over 2, I found 5 pi over 2. So that's why that's a dot as a mistake. Later on, I'm going to correct it. And then we'll have our maximum value 1.1. We'll have how many maximum value points on 2 period? 2. And I have how many minimum points on 2 periods? 2. So they are also the midpoint between the call it 1/4 point of a period. So basically the midpoint between 3 pi over 2 and 9 pi over 4. And I think I'm gonna push the paper up so we can show that. So what I'm doing now is to just try to get the minimum point. Once I have maximum point, minimum. Oh, and at the same time, all these dots that fall onto y equal to 2, if there's no vertical shift, y equal to 0, are the x equal to those value are the asymptotes for our cosecant function graph. So that's why I'm like taking my time to draw this vertical asymptotes. Once we have those, let's continue calculating the minimum value. So I didn't know that part minimum value didn't show. So okay. And I got the minimum value is 6 pi. Now I can do the dot and dash line for our sine functions graph. Okay, I push the paper up Now let's calculate another endpoint. Already did that for the second endpoint, but now we'll just do another maximum points. Actually, it's minimum because minimum, maximum, minimum. So I wrote a maximum. I'm gonna change it to minimum in a second. So I calculate that value, which is negative 3 pi. Then I figured out, oh, when I did a midpoint between the negative 9 pi over 4 and 3 pi over 2, my midpoint was wrong. It's wrongly drawn, and it's supposed to be negative 3 pi over 2. So you see, I'm changing midpoint first. Then I'm gonna find the mistake that negative 5 pi over 2 and change it. And now the midpoint I calculated is 0, but it's gonna be a minimum point, so it's gonna be 0, 0. And what's next is maximum value. And you see, I still didn't realize by then that the midpoint between the starting period and ending period was wrongly drawn. So now I'm going to figure out in a second. So we're going to calculate that's negative 3 pi. Yes. And then we found out, oh, negative 3 pi is so close to the midpoint. That's not right. So let's check the midpoint. Oh, midpoint 2, negative 3 pi over 2. So it's supposed to be 1 unit to the right. And then I thought for a while, right? Then I changed it. Yeah, see, I realized, no, it's not. That's not the midpoint. Midpoint is over here. Yes, I draw it, and that's the maximum value. Now I can draw dot, 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 dot. And okay, we finish our sine function. The reason like this period look they don't resemble each other is because that the unit I draw on the chart is not even distributed. So let's draw the, okay, that's an easy job, and I'm gonna draw the cosecant. Whenever the cosecant in the minimum value is the maximum value for our sine function, and then that's it. That's the final result for a cosecant function's graph. Yeah, let's move on to a secant function graph. That's it.